Hi, today I'm going to be examining the motions of a disk and a hoop. First, we're going to have the two objects race down a ramp, and we're going to see which one wins or if there's a tie. To do this, I've got this hoop and this disk. They have equal size and equal mass. So let's see which one wins. So it's pretty obvious that our disk is the winner. But why? What properties of the disk versus the hoop causes this one to go faster? Well, let's do some math and see what we can find out.
Using the Lagrangian, I will be finding the equation of motion for the disk and hoop. First, let's look at our coordinate system. We will be writing everything in terms of x, which is the position of the object parallel to the ramp surface. The Lagrangian is written as L is equal to T minus U, where T is the kinetic energy and U is the potential energy. The kinetic energy in this situation has two parts, translational kinetic energy and rotational kinetic energy, and needs to be written as T equals 1/2 mx dot squared plus 1/2 I phi dot squared, where I is equal to the moment of inertia of the object and is equal to cmr squared, where c is a constant associated with the object. Also, phi dot is the angular velocity and can be written as x dot over r. So, the kinetic energy equation becomes T equals 1/2 mx dot squared plus 1/2 cmx dot squared. The potential energy has to do with the height of the object on the ramp and can be written as U equals mg L minus x sine theta, where L minus x sine theta is the height of the object. Now, the Lagrangian becomes L equals 1/2 mx dot squared plus 1/2 mx dot squared c minus mg L minus x sine theta. To find the equation of motion, we need to use the Euler-Lagrange equation, which is written as shown. The partial derivative of the Lagrangian with respect to x is equal to mg sine theta. And the partial derivative of the Lagrangian with respect to x dot is equal to mx dot plus cmx dot. And the derivative of that with respect to time is equal to mx double dot plus cmx double dot. From this, we can get the Euler-Lagrange equation as mg sine theta minus mx double dot plus cmx double dot equals 0. Massaging the equation a little bit, we can get mx double dot plus cmx double dot equal to mg sine theta. And then we can pull out the mx double dots and get mx double dot times 1 plus c is equal to mg sine theta. Divide both sides by 1 plus c, and we get mx double dot is equal to mg sine theta over 1 plus c. This is the equation of motion for a disk and a hoop. As you can see, acceleration only depends on the c value of each object, which for a hoop is 1 and a disk is 1/2. Therefore, no matter the size or mass of the object, the disk should accelerate faster and beat the hoop in a race.
So we use the Lagrangian to find the equations of motions for both the disk and hoop, and we found that there is no dependency on mass or size, and that the only variable that the difference in motion depends on is c, which is associated with the moment of inertia of each object. The math shows that the disk will always beat a hoop. Now let's show it using the same disk, but a bigger hoop. The disk beat the hoop. The math was right, and we can say that no matter what size or mass the objects are, the disk will always beat the hoop. So I just have one question for you. Is there any object that can roll down a ramp faster than the disk?